To verify whether the limit for this function exists or not, just find out the left hand limit, right hand limit. If left hand limit and right hand limit at that particular value is equal, then we say that limit of a function will exist. Limit extends to a of a constant into function. So in this case, just take constant out, constant is kept out, constant into, apply the limit for limit. Limit extends to a of f of x, where k is a constant. The left hand limit as well as the right hand limit is not equal. So from the graph itself we can say the limit of this function does not exist. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class we have discussed regarding the definition of limits and few problems related to evaluate the limits. Today in this session I am going to take few more problems related to limit of a function. Now let us discuss the first problem. Discuss the limit of the function. So to verify whether the limit for this function exists or not, just find out the left hand limit, right hand limit. If left hand limit and right hand limit at that particular value is equal, then we say that limit of a function will exist. Otherwise the limit of that function does not exist. Now what is given? Discuss the limit of the function f of x is equal to 1 if x is less than or equal to 0. 2 if x is greater than or equal to 0 at x is equal to 0. Just by looking to the problem you can say that the value of left hand limit is 1 and the right hand limit is 2. So we can say that the limit of this function does not exist. Okay. Now just when x is less than 0, what is f of x? So f of x is equal to function of x is 1. So at x is equal to 0 means a is equal to 0. Write down the left hand limit. Left hand limit is limit x tends to a minus f of x. So this is limit x tends to a minus, what is a is 0 of f of x is 1, that's equal to 1. So therefore the left hand limit of this function is 1. Right. Similarly, on the other hand, when x is greater than 0, when x is greater than 0, f of x, what is f of x? F of x is 2. So therefore the right hand limit of the function is limit x tends to 0 plus f of a, that's equal to limit x tends to 0 plus, what is f of x? F of a is 2, f of x is 2. So therefore the value of limit is equal to 2. That means the right hand limit is equal to 2 in this case. So what do you say? So the left hand limit and right hand limit, check whether they are equal. Left hand limit and right hand limit are not equal. One is not equal to 2. That means the limit of this function does not exist. So therefore limit of this function does not exist. Does not exist. The limit of this function does not exist. Okay. Suppose if we draw the graph for this, let us write the graph for this. This is x-axis, y-axis 0, and x is equal to 1, 2, minus 1, minus 2, y 1, 2, 3, 1, 2, and 3. So y dash and x dash. At x is equal to 0, now what are the values we got? At x is equal to 0, the left hand limit is 1. So that is here, this is x is equal to 0, y is equal to 1. So we can write this is the value. Okay. So here this is 0 comma 1. Similarly at x is equal to 0, y is equal to right hand limit, it is 2. So here it is, we can write 0 comma 2. Okay. So here it is 0 comma 1 and 0 comma 2. So from the graph you can say that the value of x, the value of the function f of x at x is equal to 0 is 1 and the value of f of x at x is equal to 2, x is equal to 0 is 2. So that is here the left hand limit as well as the right hand limit is not equal. So from the graph itself we can say the limit of this function does not exist. Now move on to the next problem. Discuss limit x tends to 2 of f of x where f of x is equal to 3, a constant function. So discuss the limit of this function. Limit x tends to 2 of f of x where f of x is equal to 3, a constant function. So here f of x is equal to a constant function. f of x is 3. Let us find the left hand limit. Left hand limit is limit x tends to 3 minus f of x. So that's equal to limit x tends to 3 minus f of x itself is 3. So therefore the left hand limit is equal to 3. Similarly on the other hand, so right hand limit of the function, since this is a constant function, so the right hand limit 3 plus f of x, that is nothing but limit x tends to 3 plus f of x is 3, again this is equal to 3. So the right hand limit is also equal to 3. So what do you say, the left hand limits there, since the left hand limit is equal to right hand limit, 3 is equal to 3. So that means, what do you say, left hand limit and right hand limit are equal, means the limit of the function exists. So therefore the limit of this function exists, and the limit is given by the limit of this function exists, and limit x tends to 3 of f of x is equal to 3. That's it. So the limit of this constant function f of x is equal to 3 will exist, right? Now move on to the next problem. Discuss the limit of the function x plus 1 when x is not equal to 1 and 0 when x is equal to 1. So what is the meaning of x is not equal to 1? That means either x is less than 1 or x is greater than 1. So that means we can write the left hand limit. The left hand limit is limit x tends to a minus f of x is nothing but limit x tends to 1 minus f of x. What is f of x? F of x is x plus 2. So this is equal to 1 plus 2 is equal to 3. Similarly on the other hand, right hand limit is equal to limit x tends to 1 plus f of x. So that's equal to limit x tends to 1 plus f of x is x plus 2. So put x is equal to 1 plus 2 is equal to 3. That means since when x is not equal to 1, left hand limit, right hand limit are same. That is limit x tends to 1 of f of x is equal to limit x tends to 1 of, what is f of x? X plus 2. That's equal to 1 plus 2 is equal to 3, right? So therefore we can say here, therefore limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x is equal to limit x tends to 1 of f of x, that is equal to 3. So therefore the limit of this function exists. Okay, this is how we are going to discuss the limit of this function. Now if you draw the graph and verify, you can get the same result. Now move on to the next problem. Discuss the limit of the function. Now what is given here? F of x is equal to x minus 2 when x is less than 0, 0 when x is equal to 0, and x plus 2 when x is greater than 0. Now find out the left hand limit. As usual, left hand limit is limit x tends to 0 minus f of x, that's equal to limit x tends to 0 minus, when x is less than 0, f of x. What is f of x? F of x is x minus 2. X minus 2. Put x is equal to 0. 0 minus 2 is minus 2. So your left hand limit is equal to minus 2. On the other hand, when x is greater than 2, we will get f of x is equal to x plus 2. So therefore the right hand limit is equal to limit x tends to 0 plus f of x. This is equal to limit x tends to 0 plus, what is f of x? X plus 2. That's equal to x is equal to 0. 0 plus 2 is equal to 2. So here x is equal to minus 2, here x is equal to plus 2. So the right hand limit is equal to plus 2. So what do you say? Since therefore the right hand limit and the left hand limit are not equal. That is, what is the right hand limit? Right hand limit is plus 2, whereas the left hand limit is minus 2. They are not equal. So therefore the limit of this function does not exist. So the limit of this function does not exist at the x is equal to 0. That's it. Okay. Now move on to the next problem. Now very simple problem. Discuss the limit of the function f of x is equal to sin x at x is equal to pi by 2. So very simple, what is given? The value of x is pi by 2. Just find out the limit of this function. Limit x tends to e of f of x. So this is equal to limit extends to a is nothing but a extends to pi by 2 of f of x is sin x. Now just put x is equal to pi by 2, sin pi by 2, sin 90. What is sin 90? 1. So therefore the limit extends to pi by 2 of sin x is equal to 1. That's it. Okay, if you want, you can verify by using the tabular method also. That means here, what is the meaning? That is limit extends to pi by 2 minus, that is left hand limit of f of x is equal to limit extends to pi by 2 plus right hand limit, both are equal, that's equal to limit extends to pi by 2 of f of x, that is nothing but L. So both left hand limit and right hand limit are equal, so that's equal to L. So therefore limit extends to pi by 2 of sin x is equal to sin 90, that's equal to 1. Hence the limit of this function exists. That's it. Okay, these are few problems related to discussing the continuity of a given function. Now let us discuss some algebra of limits. Suppose if f of x and g of x are any two functions, then the limit extends to a of f of x plus or minus g of x is equal to, turn by turn evaluating the limit. Limit extends to e of f of x. If it is plus, put plus, or minus means minus, f of x plus or minus, apply the limit for the second function. Limit extends to e of g of x. Now the second one, suppose if it is of the form limit extends to e of f of x into g of x. So this is equal to limit extends to a of f of x into limit extends to a of g of x. Right. Suppose if it is of the form limit extends to a of f of x divided by g of x, this can be written as limit extends to a of f of x divided by limit extends to a of g of x, provided g of x is not equal to 0. Quotient rule. Okay. Suppose if it is like this, limit extends to a of a constant into function. So in this case, just take constant out, constant is kept out, constant into, apply the limit for limit. Limit extends to a of f of x, where k is a constant. So these are few algebra of limits of a function. So using this, we are going to solve different types of problems in this limits. Okay. Now, for example, let us consider, for example, to evaluate limit. So limit extends to 1 of x square plus 2x minus 1. So then this can be evaluated. Just put x is equal to 1. If you put x is equal to 1, then we will get 1 square plus 2 into 1 minus 1, that's equal to 1 square is 1 plus 2 minus 1, minus 1 plus 1 gets cancelled, let's see, that's equal to 2. So using these algebra function, we can evaluate any limits, right? So these are the few formulas which we are going to use to evaluate the limits, right? Hope you followed. That's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you very much.